Welcome! Verifying trig identities is tough, but you need to stop the voice of reason telling you you can't do it. You will figure it out, and I will show you how. When you are given a trig identity and you need to verify it, it is not an equation. You do not need to solve for anything. You are given two sides, the left-hand side and the right-hand side, and you need to take one side, simplify it using operations of addition, subtraction, multiplying, factoring it out, and trig identities. You need to take one side, work on it, simplify it, and show that it is equals to the right-hand side. How do you know when you're done? You know when you're done when your left-hand side equals the right-hand side. For example, in this trig identity, well, on the left-hand side, we have an aggregate, two fractions, and on the right-hand side, we have a cotangent. What cotangent is? You need a list of trig identities. And this is my list of trig identities. I wrote it by hand. It is this simple exercise of writing down formulas by hand is powerful. I encourage you to create a sheet of formulas as you study math and write down all trig identities. So when you simplify, you do algebraic operations and also check, is this the trig identity I can substitute? So this should be your friend. When you write down formulas by hand, you connect with them. You pay attention where patterns occur, where signs change. Do that. Okay, so when we have to verify a trig identity, we need to pick one side. Which side? The side that has more operations, more terms on it. Usually it is the left-hand side. Pick the side that prompts you to do that, prompts you to do operations, prompts you to substitute a trig identity into it. And you will work on that side. You will perform operations. You will apply trig identities. Sometimes you need to rewrite in terms of sines and cosines. For example, when I look at the right-hand side, what do I see? I see a cotangent. What a cotangent is? Let's look at quotient identities. Cotangent, it is, so we have 2 times cosine of theta over sine of theta. So I need to simplify my left-hand side to show that it is equal to the right-hand side. So I need to see at the end that this is what I get. Okay? So let's go and simplify this example. Let's simplify this trig identity. So I'm picking the left-hand side because there are more things to do. On the right-hand side, that's it. I stop. There is nothing much to do. So on the left-hand side, I see 2 fractions. What do? I subtract fractions with different denominators. So I have to multiply my denominator. So what will be my common denominator? I will multiply them. So 1 minus cosine of theta times 1 plus cosine of theta. Now I have to change each fraction into its equivalent one. I multiply the first fraction by this denominator. So multiplying 1 plus cosine of theta over 1 plus cosine of theta. Okay, and this second fraction I will multiply by this denominator. 1 minus cosine of theta over 1 minus cosine of theta. Okay, now I have to carefully multiply. So multiplying sine of theta. Sine of theta plus sine of theta times cosine of theta. Done. Now look at this. We have minus here. So we make sure we don't mess up with signs. If we mess up with signs, we may not recognize a trig identity because our signs change. So pay attention. I grab this negative and take it along with the sine of theta. So minus sine of theta, I am multiplying against everything. Minus sine of theta times minus cosine of theta. Minus times minus will give me plus. So plus sine of theta times cosine of theta. Okay? Now let's stand back and check. It's important to check. There is no way to rush it. It's easier to check each step rather than be lost and mess up the signs. Okay, nice. Look what I see. We can cancel out this sign and combine these two terms because they're identical. You see, we are doing algebra at this point. Can we see any trig identities here? Not yet, but let's see what happens. So combining these two terms, I will have 2 sine of theta times cosine of theta and my denominator. Let's go ahead and let's leave it alone for now. I'm gonna just rewrite it and stop and evaluate what I have. If I zoom into the numerator, do I have something to simplify? Do I have any trig identity? You see, I need to have a list of trig identities close to me so my eyes can constantly check or get familiar with your trig identities. I have a double angle formula here. So the numerator is sine 2 theta, but that's a double angle. You see, 2 theta. I have, what my goal is to have cotangent of theta. You see, it's a single angle, 1 theta. Do I want to substitute this identity double angle formula? Probably not, because I have a single theta. Here it's a double theta. So I will not use that identity, but I saw it. It's in the numerator, but I will leave it alone. I will leave my numerator alone. What else can I do? My goal is this, yes? Did I arrive at? No. So I have to keep going, to keep simplifying until I arrive to 2 times cosine over sine. That's my 2 cotangent. Okay, what is there to do? Probably unpack the denominator. Let's go. Numerator has nothing to do. Denominator has. Let's go and multiply. So I will use the distributive property. I'll take 1, multiply by each. So rewriting my numerator, since it didn't change, lost my theta here. So 1 times multiplying everything by 1. So it will stay the same. 1 plus cosine of theta. Done. I multiplied everything by 1 in these parentheses. Grab negative cosine of theta and multiply by each. You see, again, pay attention to the sign. Make them bold. Negative cosine of theta times 1. Minus cosine of theta times 1. Negative cosine of theta. Negative cosine of theta times cosine of theta. Negative cosine squared theta. Okay, that's my denominator. Let's see, can I reduce something? It looks like I can, this cosine of theta will collapse. Okay, let's see what's next. Let me erase here so I have room and you guys can see. So, rewriting my fraction. 2 sine of theta times cosine of theta. What do I have left in the denominator? I have 1 minus cosine squared theta. Now, I'm stopping. Do I have any trig identity that I can substitute? Okay, remember we have the Pythagorean theorem. We have sine squared theta plus cosine squared theta equals 1. Wow, look at that. If we rearrange terms here, subtracting cosine squared theta from both sides, we will have sine squared theta equals 1 minus cosine squared theta. That's our denominator. And we are gonna just substitute. We are gonna use the Pythagorean theorem and substitute in the denominator. Look, it's getting better. But we just have to jump in and do something and just try. You guys will figure it out. You will work it out. Let's go. Substituting the Pythagorean identity in the denominator. 2 sine theta cosine theta. Down there in the denominator we have sine squared theta. Write it nicely. Now I can cancel out my sines right here. What do I have? I have 2 cosine of theta over sine of theta. What do I have? I can use the quotient identity. I see quotient identity. Aha, that's my right-hand side. So I showed that the left-hand side, 2 times cotangent of theta, is equal my right-hand side. The left-hand side equals the right-hand side. That's when I stop. And I show that I proved this trig identity. I simplified using the operations and I applied trig identities on the way. Look at what you have, the problem you are working out. Get familiar with trig identities. Have it by your side. Make sure you constantly check. You can do it. You will work it out.